Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from limits and continuity, right? And here we are going to solve this important problem, that is, if we have the function f of x is equal to square root of 1 plus signum of x, then we have to find the right hand limit and the left hand limit of this function when x approaches to 0, right? So this problem is a very important problem for beginners, right? So let us see how we can find out the right hand limit and the left hand limit of this function involving the signum function when x approaches to 0, right? So let us start. So here, first of all, what we will do, we'll first take the definition of signum function, right? Because while finding out the right hand limit and the left hand limit, we'll use the definition of signum function, right? So now see, we can define signum of say y is equal to plus 1 whenever y is greater than 0, right? And signum of y takes the value 0 when y is equal to 0, and signum of y takes the value minus 1 whenever y is less than 0, right? So for all positive values of y, signum of y is always 1, right? And when y is 0, then signum of y is equal to 0, and for all negative values of y, signum of y is minus 1, right? So this definition of signum function is going to be of prime importance, right? So now let us first find out the right hand limit, right? So now we can, the notation for right hand limit is limit, and here we have x tends to 0 plus, right? So this positive sign shows that we are approaching towards x is equal to 0 from the right of x is equal to 0, right? So right hand limit is limit x tends to 0 positive, and here we have f of x, right? So now see, when we approach towards x is equal to 0, we are in the neighborhood of x is equal to 0, that is, we are at this point say a, and this point a is very close to x is equal to 0, right? So to express this neighborhood, we introduce the parameter h. So we'll take x is equal to 0 plus h, right? So this point a is 0 plus h, that is equal to h, right? So here x is equal to h, and when x tends to 0, then obviously h tends to 0. And always remember that this parameter h is a positive quantity, right? So h is positive quantity and it lies between 0 and 1, right? And h is a very small quantity. So now the right hand limit is given by this expression. So we can now write the right hand limit as limit, here x tends to 0 plus can be written as h tends to 0, and here we have f of x. For x we can now write h, right? So now we have limit h tends to 0, and f of h can be obtained by replacing x by h. So here we have a square root of 1 plus signum of h, right? Because we are now replacing x by h. So now here we cannot directly substitute h is equal to 0, right? So what we will do, to get the value of signum of h when h tends to 0, we'll utilize this definition, right? Now see, h is a positive quantity, and see here y is greater than 0. It implies y is positive, right? So when y is positive, signum of y is plus 1. So signum of h, this signum of h is equal to plus 1, right? So because h is greater than 0, that is h is positive, right? So here always remember we cannot substitute directly h is equal to 0. So now we have a limit h tends to 0, and we have a square root of 1 plus, and signum of h is now 1, so here we have 1, right? So now this is square root of 2. So 1 plus 1 is square root of 2, and since this expression does not contain the variable or the parameter h, so we'll remove this limit notation, right? So the right hand limit of this function when x approaches to 0 from the right of x is equal to 0 is square root of 2, right? So the right hand limit is square root of 2. So now let us find out the left hand limit. So the notation for left hand limit is limit x tends to 0 minus, and here we have f of x, right? Now in this case, when we are calculating the left hand limit, we are approaching towards x is equal to 0 from the left of x is equal to 0, right? So we are now in the left neighborhood of x is equal to 0. So here we have the point B, and this point B is 0 minus h, right? So while calculating the left hand limit, we take x is equal to 0 minus h, right? That is x is equal to minus h, and the other conditions remains the same. That is when x tends to 0, obviously h tends to 0, and h is positive quantity, it lies between 0 and 1, and h is very small quantity, right? So now this limit can be written as limit in terms of h. We can now write limit h tends to 0, and for f of x we can now write f of minus h, because x is now minus h, right? So now we can here write limit h tends to 0. F of minus h can be obtained by this function. So we have square root of 1 plus signum of minus h, right? So here we have replaced x by minus h, right? Okay, now again here we cannot directly substitute h is equal to 0, right? So we'll again use the definition of signum function. So see, we have already said that h is a positive quantity, right? So when h is positive, then minus h is a negative quantity, that is minus h is less than 0. So whenever we have y less than 0, then signum of y takes the value minus 1. So signum of minus h would take minus 1, right? Because h is positive but minus h is negative, that is less than 0. So signum of negative quantity is minus 1, right? So now this limit is the limit h tends to 0. We have square root of 1, and here signum of minus h is minus 1, right? So now 1 minus 1 is 0, so the limit becomes 0, right? So the left hand limit of this function when x approaches to 0 from the left of x is equal to 0 is 0, right? So viewers, here we have seen that the right hand limit is square root of 2 and the left hand limit is 0, and both the limits, although both the limits exist and they are finite, right? So both the right hand limit and the left hand limit exist and finite, but the right hand limit is not equal to the left hand limit. So we can claim that the limit x tends to 0 f of x, that is square root of 1 plus signum of x, this does not exist, right? So the limit of this function when x approaches to 0, it does not exist because the right hand limit is not equal to left hand limit, right? So this is how we can solve these type of problems.